All right, in this video, we will go over test one. And I'm just going to go over the problems that had like some math component or just some problems I want to point out that just need a little bit explanation because most of these, they have the answers selected. So I'm just going to go over number two quick. So what's the oxidation state of carbon and COO minus? So remember, all their oxidation states have to equal to -1. Oxygen's always -2. Then carbon is +3. Consider the following metabolic reaction. What is delta G? So given a delta G naught prime in a temperature and concentration. So delta G equals delta G naught prime plus RT ln KEQ. Or in this case, it would be Q. KEQ is for equilibrium. Q is for solving delta G. So we have 4.4 plus R, 8.314 times 10 to the -3. And it's to the -3 because we want to work in kilojoules times temperature in Kelvin. So it's 273 plus 37, which is 310, ln products over reactants. So our products are 0.290 divided by our reactants, which is 3-phosphoglycerate, which is 2.90. And there we will get our delta G, which should be negative 1.53. All right, so consider this reaction negative, so favorable under standard conditions there. All right, so 6, given the standard reduction potential of oxaloacetate is negative 0.166 and NAD is negative 0.315, what is delta E? All right, so for this, we have to figure what's being oxidized and what's being reduced. Negative 0.315 minus 0.166, and we get negative 0.149. So that is delta E. All you have to do is add these two values in the correct order. All right, so so again, all these have answers. Don't really need to explain too much of those, but 10, let me just talk about 10 a little bit because it is quite a complicated question. So we have K, and basically what I have here, this is glycolysis, she's using numbers and letters. So K inhibits enzyme 5, right? So that means we are under allosteric control. Allosteric just means something is binding. Covalent would be like adding a phosphate. Genetic would be changing the levels of the protein through RNA, basically. So we know it's allosteric. All right, so if enzyme 3 is activated by pKa, all right, pK, we talked about this in class. What pKa does is it phosphates stuff. So that means enzyme 3 is getting a phosphate attached to it. This is covalent modification. Genetic, again, is if RNA levels are changing. So already we can figure out the answer, but let's continue. If enzyme 2 is only expressed in the high concentrations of A, so here we're talking about expression levels, so that's genetic. If all these are true, then what will decrease flux? So K stops enzyme 5. So K is stopping it. Your other example is A. because I only give you two choices, K or A. And here it's saying A is activating enzyme 3. So it has to be K is decreasing flux. So that's why the answers line up that way. So just, again, these are all the answers there, not much to explain there. And you can look at these at your leisure if you look at your own tests. Again, I'm just looking for any questions that I feel need to be explained a little bit more. And I don't think there is. Like, hopefully once you see the answer listed out, that they'll be like, oh yeah, that's why it is. However, if there is a specific question where you don't understand why the answer is the way it is, let me know. It's possible that I put the wrong answer in the answer key, so I'll be happy to discuss with you further. Otherwise, if you have any questions how I scored anything, always let me know. Otherwise, that is it for this video. I'll see you in the next one.